Hello, I'm Nathan DeMay from Configure Consulting, and I will be presenting today with Chip Sutton from EView Technology. A few items to keep in mind during this presentation. This webinar is being recorded. All lines have been muted. Please do not put your phone on hold or answer another call. Your hold music may play. Questions can be posted in the Question Manager and will be addressed at the end of this presentation. The agenda for today's webinar includes a review of mainframe discovery and transitions, an overview of EView discovery for HP UCMDB, process considerations and roadmap, a demonstration of discovery results by Chip Sutton, a look at Configure Consulting's best practices regarding EView implementations, and finally, questions and answers from the audience. I want to give a brief overview of Configure Consulting for those on the call who may not be familiar with us. Configure Consulting specializes in staff augmentation and consulting services across HP software, VMware, EView Technology, and other IT operations vendor portfolios. Our unique Quick Start solutions are designed for efficiency, stability, and top performance in the delivery of business services. We have successfully completed hundreds of projects with many Fortune 500 clients across North America. Our experience implementing EView includes helping a large financial services company to map discovered mainframe data into their application maps, allowing change managers to visualize the impact of a proposed change right down to the mainframe level. We also implemented EView for a client to minimize risk and impact while they were decommissioning mainframes and moving away from legacy systems. And finally, our experience shows that reports on mainframe discovery and dependency mapping are hugely valuable to mainframe teams, particularly when we clearly trace out how the physical systems impact frontline applications. Here are some of the most common use cases for supporting mainframe transitions. EView Discovery collects mainframe configuration items for populating the HP UCMDB. The discovered information includes LPAR and operating systems, DB2 subsystems, CICS regions, IMS subsystems, Sysplex, network information, installed software, and MQ subsystems. This highly flexible auto-discovery enables the UCMDB to maintain the most precise and current configuration item data, providing the enterprise with a single point of accuracy for the mainframe data. The HP Universal Discovery provides the basis for understanding the components that make up the services that IT delivers, from the physical layer of the data center all the way down to the business process layer. With application mapping, we can tie physical infrastructure to the overall business applications and services that rely on this infrastructure. This rich application mapping and auto-discovered data provides the ability to perform impact analyses based on a mainframe distributed infrastructure. If there's a system outage, this allows users to pinpoint what is impacted, including which applications. Additionally, users can leverage real CI data in the ITSM toolset for change and incident management. Now Chip will discuss how EView works in some more depth, and then he'll be doing a live demo of the product.
So first I want to talk about how the EView product integrates with UCMDB. The basis for the discovery is an EView 390 agent that resides on each LPAR to be discovered. There is also an EView client that's installed on the Universal Discovery probe. It is the client that communicates with the agent and allows the discovery jobs to get the information needed to do the mainframe discovery. In this chart, you can see the flow where the discovery job that's sent to the probe executes a local shell command, which is an EView client command, which sends a request to the agent to run a command or Rex program or subsystem commands like MQ commands and DB2 queries, or requesting the agent to gather information internally and send that information back to the EView client, which then goes back to the script that parses the output and creates the configuration items and links in the CMDB. The EView discovery installation process starts out on the Universal Discovery probe. The client is installed on the probe, and an EView configuration manager is used to configure the LPARs that will be discovered and set the parameters and options in the discovery jobs. There's also a set of files on the probe that need to be transferred to the mainframe for the agent installation. The agent installation involves restoring these files and configuring the agent, and also configuring security product access for agent access to be able to issue the discovery commands and access the different subsystems that will be discovered on the mainframe. This is just an outline of what we'll look at in the demo when we switch over to the UCMDB interface, looking at the LPAR discovery and how some of the different mapping is done for the physical machines, LPARs, host dependencies, storage groups. We'll also look at DB2, IMS, CICS, and MQ, and how some of those dependencies and relationships are created in the CMDB, as well as CICS region, list group transaction, program detail. So currently, we're looking at the UCMDB interface in the Discovery Control Panel. On the left-hand side, you will see the folder for mainframe. This is the mainframe discovery adapter. This is installed as part of any content pack installation that's done with UCMDB and includes the different discovery jobs for the mainframe. For example, the one highlighted is the EView connection job, which is the first discovery job that occurs for mainframe discovery. Its purpose is to find mainframes that have the agent installed, verify that the agent is running, and create a configuration item for the actual ZOS operating system. This is then used as the trigger for the remaining jobs, like the LPAR resource job, which discovers typical host resource information like network interfaces, IP address, IP endpoints, disk storage, CPU memory, very typical host information, but it also discovers information about the relationships between LPARs and physical machines, as we'll look at here with the results from this particular discovery. So if we look at, for example, a mainframe CPC, which is a central processing complex, is the physical machine. When we look at the physical machine, we can see that there are two ZOS LPARs that were discovered. And as we drill down to the ZOS LPARs, we can then begin to see some of the information that was discovered. For example, we can look at interfaces, and we see five network interfaces that are defined on this ZOS LPAR. And if we want to see what's defined for this interface, for example, discovered the IP address and what the IP address is for this particular interface. We can also drill down and look at other host resource information. We can do it all on one screen, but for the purposes of the webinar, because these screens can get a bit busy and hard to read, I'm going to drill down separately and look at some of the different items that are discovered. For example, looking at storage groups that are defined. Storage groups are mainframes are very similar to file systems on other platforms. Storage group consists of different disk volumes. So if we want to see the storage groups or volume groups that are defined on this particular LPAR, we can choose that and see that this particular case we have 10 different storage groups, and if we want to know the volumes, the disk volumes that are defined in that storage group, then we can drill down and see the actual volumes defined in each one of these storage groups. Let's take a look at DB2 discovery and see what's discovered there. We typically discover data sharing groups, distributed data facility, databases. Table spaces can be discovered. It's an optional discovery, but it can be turned on to discover, go down to the table space level. But we'll take a look at some of the typical things that are discovered with DB2. We'll start with the DB2 subsystem, and there was one discovered on this particular LPAR. And when we take a look at that, we can see what else is discovered. For example, there's one distributed data facility defined for remote access to this particular DB2. We can also look to see that there are 37 databases that are defined in this particular DB2 subsystem. Taking a look at CICS, discovers normally CICS regions. However, optionally, you can have it go down to the detail level to discover CICS lists, groups, transactions, and programs. And we can take a look at some of those discoveries and the relationships that are created with the CICS discovery. If we start at the CICS region of which one was discovered on this LPAR, we can take a look and see that in this region there are 2 lists defined for this region. And as we go down the list, we can see this particular list has 8 groups. And if we select a particular group, we can see that it has 1 transaction defined. And then as we look at this transaction, we can see what program is executed by this transaction. For companies that still are using IMS software for transaction database processing, we have the IMS discovery that looks at IMS subsystems, IMS regions, can go down to the transaction and program level as well. If we take a look at the IMS subsystem here, we have 1 that was discovered. And as we look at that IMS subsystem, we can see the different types of configuration items that were discovered with databases, database areas, programs, regions, and transactions. So we see this particular IMS has different regions, and we can see the different regions that we have. For example, DL1 regions, we have some batch regions as well. We can also go down and take a look at transaction program information. In this case, there are 19 transactions defined for this CICS, this IMS region. And we can then go to that go to a transaction, see what program is defined and executed by that transaction. And the last discovery we'll take a job we take a look at here is the MQ series discovery, where we discover MQ managers and information about channels, queues, and processes and data sharing groups. We can take a look at the results here and see some of the different items that were discovered. We take a look at the MQ manager, and we'll look at well, an example of what was discovered here, starting with the MQ manager. And we see a number of different discovery items, but we'll take a look at one of these, for example, the receiver channels. And we can see some different receiver channels, and we select one of these and see that this particular channel also has a sender channel associated with it. When we look at that and look at the sender channel, we can then see the queue that is used. And then as we drill down to the queue, then we can then actually see the relationship being built between the sender channel and the receiver channel using the local queue. You can also use the modeling studio to create different views for the discovered data. I'm going to switch over to the modeling studio and show you one particular view that seems to be very interesting for a lot of the mainframe discoveries that are done, and that's the dependency mapping view that's using data discovered by the LPAR resource discovery job. In this view, we can see the different mainframe LPARs and connections that are created to other systems, and I'm going to make this a little easier to see right now, but you can see a number of connections that were created. During that dependency mapping. So at this point, I'm going to turn it back over to Nathan, who's going to talk about Configure Consulting's best practices.
Thanks, Chip. So our best practices framework for implementing EView. Firstly, we deploy the EView agents to the physical mainframes. Next, we run discovery in UCMDB and update, if necessary, application models, impact analysis, and reporting scenarios. These activities result in end users being able to see mainframe data conveniently in a browser or from automated reports out of the UCMDB. Finally, we modify ITSM and monitoring integrations to incorporate the newly discovered mainframe data. And with that, we'll open it up to questions. I've got a couple of them here. The first one, is EView compatible with the latest releases of HP UCMDB?
Yes, EView is compatible. I believe the latest version is 10.20 with Content Pack 15. The mainframe adapter originally was released in Content Pack 8 and has existed in all of the Content Packs since that time, with both UCMDB 9 and now UCMDB 10.
Okay. The next question is, what are some examples of EView discovery reports that may be useful to our mainframe team?
With our customers today, we find there's a number of different ways the mainframe teams use the data. One of the ways is just to look at the different configurations for the many subsystems that they support, and being able to see what's actually defined in the systems. A lot of changes can occur in mainframe systems over the years and to the configurations of the different subsystems. Having the discovered information allows the administrators to see what's discovered, ensure that what they have is current, also to be able to clean up old discovered items or configurations as applications change and new configurations are put in place. Sometimes the old ones aren't removed right away, so if there's old configuration data that exists, they can remove that configuration data, and free up resources or memory within those subsystems. Also, in terms of using the data for change control. Typical mainframe change controls are pretty rigid and have defined windows when changes are made, and the mainframe administrators that make those changes can use the reported data from UCMDB to be able to verify changes that were made during the change window to make sure that everything was changed, or make sure something that wasn't planned maybe accidentally was changed during the change window as well. And then the dependency mapping that I showed you is another one of the areas that can be of interest to a lot of the mainframe people, in terms of seeing all the different systems and being aware of all the different systems that are actually making connections to that mainframe LPAR.
Okay. We've got another question. Is there an agentless / credentials-based discovery option available for EView discovery?
No, the architecture and the way the mainframe operating system works, it really isn't conducive to doing an agentless discovery. That's why we have the agent to do that discovery. The agent is a very lightweight agent. In fact, in a discovery-only environment, the agent is actually sitting passive on the mainframe, waiting for the discovery jobs to make requests. But because of also the security architecture of the mainframe and how it's implemented with the various subsystems, would make it very difficult to do any kind of agentless discovery.
Okay. That's it for the questions that we have for today. I just want to thank everybody for your time and attention. And our contact information is on this last slide. Feel free to get in touch with us if you have any further questions. Thank you.